Today we are discussing a new collaboration between ENODA and Mersen, focusing on ENODA's new flagship device, the Enoda PRIME Exchanger. I am joined here in Paris at Mersen's headquarters by Jacqui Porch, founder, Chief Markets and Communication Officer at ENODA. Welcome, Jacqui. And Dr. Philippe Roussel, VP for the Power Stack product line and Executive Open Expert at Mersen.
What the Prime Exchanger is seeking to do is active signal correction. So it is situated in the location of a substation in the distribution network and is actively, so in real time, correcting electricity signal that flows through. So the power electronics stack in that hardware platform of the Prime Exchanger is fundamental to being able to do that.
Yeah. It's interesting what you say, because that's really this real time that is a key challenge for power electronics, meaning we have to react extremely fast.
Yeah.
And this is where silicon carbide can offer a lot. And for us, that was really how we could take advantage of all the silicon carbide technology, including very high switching frequency, low losses as well, because in the end it's also a question about efficiency, power efficiency. So we have to really work with silicon carbide with as low losses as possible. And just maybe to anticipate on the technology, this power stack is about, it's 2 times 160 kilowatts, so meaning it's almost 350 kilowatt total, so it's a lot. And despite we're using SiC, losses are not null, there are losses, and we have to manage losses. In such a configuration, it was about 4 to 5 kilowatt of losses to be managed, so to be extracted from the power electronics. And we had to live with that since the day one, how to handle that in a very condensed way, because in fact you wanted this stack to be not too big, so we had also to make some improvement on the footprint. And in the end, we ended up with a configuration using a DC link around 800 volt DC, almost I would say it's 200, 300 amp depending on the configuration, and approximately 30 kilohertz switching frequency. So altogether, it makes it really first exciting, but challenging too.
Yeah, exactly. And you know, having you mentioned footprint, and that is one of the critical pieces. The Prime Exchanger is it's a backwards compatible technology, so it needs to be able to fit into existing substations. So you know, the silicon carbide, the power density, reducing the footprint. It also has implications for the economics as you start to produce more and more. So yes, making it as small as possible. Number one challenge.
Yeah, as small as possible, with a very
and fast.
Very highly demanding thermal management in such a small area. So we have to find some smart solutions to make it happen.